All right, so this is part two of um, regression analysis, where we're trying to find the coefficients for the line that can be a good fit to a set of data points. So we talked about how we calculate the G matrix, and after calculating the G matrix, we have to calculate the right-hand side, and the right-hand side involves with RIZ, RIZ1, RIZ2, all the way to RIZN, depending on how many parameters we have. Okay, so I think we covered how to calculate RIZ1. For RIZ2, well, we know that Z2 is going to be Xi, according to what we calculated for the linear fit. And then Ri, we just said it's going to be Yi, because Ri should be calculated when both parameters C1 and C2 are 0. So anyways, this is sum over Yi Xi, because Ri is Yi. And then, so we can create a column for Yi and calculate this Xi, Yi as the sum product, and then put them in here. So by solving this system now, we can solve for C1, C2. So this C1, C2 is nothing but the change in C1 and C2 from the point that we initially guessed to be 0. So anyways, by solving this system, we can get C1, C2. Let's look at one example here. So this is the evaporation coefficient calculation. We have the air velocity, and then we have the evaporation coefficient, which is pretty much like speed of the evaporation as a function of air velocity. So we know that as the air velocity goes up, the evaporation goes up, and so we can sort of see this. But if you plot them on like XY axis, you see that it's not really following, so the data is not following a line, it's like around the line. But the question is, what we really want to find is a good fit. Like, can I just fit a line to this data, to this set of data points? Okay, so remove these lines. Okay, so what we can do is we can go ahead and calculate the coefficients C1 and C2 using a spreadsheet. So here is the spreadsheet. That is example 7.1 in the textbook. Okay, so first we put in the data. So this is the X and Y data, right? And then what we need is, according to the G matrix, we need Z1, Z1, we need Z1, Z2, we need Z2, Z2, right? So Z1 is nothing but 1, so we don't do that. Z2 is going to be X squared, so we create a column for that. So this is X squared. For every X, we calculate X squared, and then we get sum of the X squared, okay? So this is going to be sum of Z2, Z2, right? Well, Z2 is Xi squared. Then we need the sum of Z2, Z2 for the G matrix, if you remember, right here. So this is basically sum of Z2 times Z2, which means sum of Xi squared. We also need sum of X to put them here, and then this is still 10. Okay, so here's 10, then this and that. The diagonal elements will be sum of X, which is, I have here, that's the sum of X, right? Is 2000. And then sum of X squared is 532,000. So that's sum of X squared. Now I have a matrix for G. The right-hand side, I need first a sum of Y data. So this is the Y data, and here's the sum of Y data. Okay, so you can easily get the sum function in a spreadsheet. So that's the right-hand side. That's the sum of the y's, and then we also need sum of the yi. Let's see, it was sum of yi xi. So I also need the cross product. Okay, so here's the sum of xi yi. For every xi and yi, you can calculate the sum. You just drag this guy down to here, and then you're going to have the xi yi. You can calculate the sum, and the sum goes to the second element of the right-hand side. Okay. So now we have the right-hand side, we have the G matrix. We can go to the matrix package. You see that it's already it's ready here. I have the button here, and solve the system using syslin with this coefficient matrix and this right-hand side. If you go ahead and solve it, you get the C's. So the fit is going to be, this is C1 and this is C2. So it's going to be, this is the intercept and this is going to be the coefficient for the X. So it's going to be this, which is 0.0692 plus this times X. So here is the fit. So here's the line. You can go ahead and draw this line in the spreadsheet or in Excel. You can basically draw the points. So here's the y as a function of x for 10 data points, and here's the fit line, which actually match the data the best. I mean, that's the least error we get. If you have another line different from this, the error we get is going to be higher. So how we can calculate the error? Well, now we have the function. We can calculate the y for each x. So the calculated y is going to be C naught or C1 plus C naught. Let's say this is C naught plus C1 times the x value. So it's the blue times the x value plus the green. I'm sorry, blue plus green times the x value. So it's blue plus green times the x value. But because these two are fixed, we're going to freeze the numerical and letter indices. And after doing so, we can just drag this guy down. And they say this calculates the y for us. So you get the y calculated. Then we get the difference between the y calculated and the exact y, which is the experimental value. So that's going to be the difference between this column and this column. We can just drag this guy down. And so now you get the residual. Then you get the residual squared. So here's the residual squared, which is nothing but yi minus y calculated squared. And then you can sum over all of them, you get this. So this is the total error we're making, 0.2. So the upshot is, if you use any other line, if you use any other coefficients for this fit other than these, the error you get is going to be higher. And you can easily test this. Well, I don't have it here, but if you choose your C1 and C2 and just do the same calculation and calculate the residual squared, you would see that the error is more than 0.2. Okay, so this was example 7.1 in the textbook, how to calculate the best fit using a linear regression. This is a linear regression because we're just fitting a line. You can also look at the residual in a scatter plot. So for every point, I'm just plotting the residual, which is this column. So this column against this column. Okay, so that's the residual. And you see that residual is up and down. Some points deviate more from the line, and some points are like this one is very close to the line. So the height actually shows the residual. Okay, so I hope this is useful. So stay tuned for the next video on regression. So in the next video, we'll be looking at the second example in the textbook, which is now where we're going to go beyond linear fit and look at nonlinear fit. Let's say we're going to fit a parabola to a set of data points. Okay, then we can see how we can do this. And how we can derive the coefficients C1, C2, and find the residual and basically the G matrix on the right-hand side. Okay, so thanks a lot for watching. Stay tuned for the next video on the regression.